So the audio is pretty quiet last time, so I have fixed that. Today we are going to go over electrochemistry. Now, electrochemistry is supposedly the hardest thing in chemistry, but as somebody that just tried Cambridge, it's very easy, and it have like three rules that I had to know. No, one rule that I had to two rules that I had to know to be able to do good in electrochem. So I'm going to start from the very start, right? Electrochemistry. Um, the main part of electrochemistry is a process called electrolysis. And electrolysis is simply defined as the breakdown of an ionic substance in the aqueous or molten state by passing electricity through it. This is a 2-mark response. A 1-mark response is the breakdown of an ionic substance by passing electricity to it. Right? Right. That is the definition of electrolysis. Now, the apparatus for the electrolysis looks like this. Right? There is 2 of these things and a beaker or some form of container, and something is in the beaker. Okay, so what exactly is this apparatus? This on the outside is a beaker. This is these two here are electrodes. And this here is an electrolyte. Okay? This is just a battery. Or some form of power supply. Okay? Cool. Now, there are 2 types of electrodes. The anode and the cathode. Right? Now, the anode and cathode are somewhat weird. Okay? The anode is the positive terminal and therefore attracts anions, which is the negatively charged ions, right? And the cathode is the negative terminal and therefore attracts cations, the positively charged ions, right? Cool. Now, at the anode, oxidation occurs. I will go into this later on. And at the cathode, reduction occurs. Right? So another thing to prove that the oxidation and reduction occurs, right? From electricity flows from the anode to the cathode. So let's say if this was the anode. So I'll put positive, negative, right? It flows from the anode to the cathode. So like this. Right? So therefore the electrons move from up here through this all the way down to here. Okay? That's the direction in which electricity moves. I don't think you need to know that for CSEC, but it's good to know. Okay? So now we're going to go into the electrolysis of aqueous electrolytes. Now, aqueous electrolytes will always have 2 sets of cations and anions in them. 2 sets of cations and anions. Right? Because it's aqueous, aqueous means it was dissolved in water. So the water ionized, so therefore H plus and OH minus will always be present in an aqueous electrolyte. Okay? And, okay, so let's say we had, for instance, CuSO4 aqueous. I don't think that exists. No, it does exist. Right? Let's say we had CuSO4 aqueous. Right? And we want to electrolyze it. Electrolyze it, whatever it is, right? We would have the Cu2 plus ion, the SO4 2 minus ion, the H plus ion present, and the OH minus ion present, right? But the questions in the exam does ask you to write equations and things for what going on at the electrodes, and we had to be able to identify what being formed. We have two sets of cations, and two sets of anions. How we just know which one going to be at the which one gonna form. So there is a fairly straightforward flowchart to do this, and I'm going to draw that off camera. Right, so I draw it here, and I'm gonna break it down now. Right, so it starts off with a simple question: is the anode active or inert? Now I did not go over what is the difference between an active and inert anode, so let's do that. Inert anodes do not interfere with the reaction, but it still can conduct electricity. For example, graphite. Graphite is inert because it can conduct electricity, but it isn't involved in the reaction. An active anode, like you say we had a copper anode, the copper anode is active because the copper can interfere with the reaction. So examples of active electrodes: copper, magnesium, any others? Zinc, copper, magnesium, iron, sodium. The only ones that aren't in it, the only ones that aren't active in it would be graphite, which is just carbon, diamond, which is also just carbon, and platinum. Platinum is basically unreactive. Okay, cool. So if it's active, the anode is active, then the anode itself ionizes. So let's say we had a copper anode, then the copper itself ionizes, and the anode oxidation occurs, so the Cu becomes Cu2 plus. Right? If I had to go over oxidation and reduction, I could do that. Don't worry. Now, if it's in it, then the next question could be asked: is the electrolyte a concentrated halide solution? Halide meaning is Cl minus, F minus, Br minus, or I minus present. If any of these are present, then the halide itself is discharged. But if it's not, the ion lower in the electrochemical series is discharged, which is usually OH minus, right? I will go over the electrochemical series afterwards. I'm gonna do an example question. Let me find one. Okay, so here we have a pretty good one, right? As a multiple choice question. Solid lead bromide is heated until it is molten. The molten lead to okay, no, this is a better question to explain what molten is. So molten means that it somehow became, basically the liquid form, but not aqueous, so no H plus and OH minus absent. So this one you would straight up just see what you see up here. Lead bromide, lead, so lead is Pb plus, and bromide is, no, lead is Pb2 plus, and Br is Br minus. So at the anode they would get bromine, at the cathode they would get lead. Let's see, oh my god, I love this thing, man. Okay. Medium, we get a little bit of dilute sulfuric acid is electrolyzed using inert electrodes. What are the products of this electrolysis? So, using the flowchart, we could solve this. Okay? So, is the anode active or inert? Inert electrode, so it's inert. is the electrolyte a concentrated halide solution? Sulfuric acid is H2SO4, so it's not. So that means the ion lowest in the electrochemical series is discharged. Therefore, it's usually OH minus. In this case, it is OH minus. When OH minus is at the anode, it forms oxygen, not hydrogen. So it would be the only option with oxygen at the anode is D, and we're going to go over why hydrogen is formed at the cathode. Right, so here is the electrochemical series. Right here. This is the electrochemical series. Potassium, calcium, sodium, magnesium, aluminum, zinc, iron, lead, hydrogen, copper, silver. Now, it looks like a lot to remember, but if I'm gonna be completely honest, you just have to remember which one's above hydrogen and which one's below hydrogen, and they should be good to go. Now, the trend in this is that as it goes down, the ease of the discharge increases. So let's say we had four different cations present in our solution: K plus, Mg2 plus, Zn2 plus, and Cu2 plus. Which one would be expected to form at the cathode? It would be the one that is lowest in the electrochemical series, which, again, all we had to know is which ones are lower than hydrogen. You just had to remember hydrogen, copper, silver. So because copper is here, that's the one. They will never ask you between lead or like potassium or any of like these four specifically. They won't ask you for that to be low hydrogen, because I just doubt it. It have no way. Right? Don't quote me on that, please. Anyways, that's the electrochemical series of cations. For anions, it is right here. I'll send this in the. I'll put this in the description or something. Displacement of nonmetals. This is the electrochemical series of anions, and again the ease of discharge increases downwards, and I believe that is all we have to know about this aspect of electrochemistry. Now, electrochemistry has its applications. There are a few. There are, I believe, 3 major ones. Right? So, electrolysis is used in 3 different processes. Primarily, the extraction of metals, electrorefining, and electroplating. Right? And once you understand the concepts went over here, that electricity flows from the anode to the cathode, you're set. That's like, once you know that it moves from the cathode to the from the anode to the cathode, you're set. And if you don't understand that, I'll elaborate. So let's say we have Cl minus and Na plus, right? Let's represent this using their valence shells. Actually, no, I'll do it. I don't need to. So Cl has one more electron than it should have, and Na plus has one less electron than it should have. Okay? So if it wanted, let's say one have one more and one have one less than it's supposed to. So if we get rid of this one more, then we'll just get Cl, which is what we want. And then down here, where does that electron go? It goes to the one that have one less. If it have one less, and we get up one more, then a normal again. That's the premise behind ionic equations as well. Now we have NaCl because they basically just share the electrons. Right? Cool. Once you understand the premise that electrons move from the anode to the cathode, yes, that. So let's explore these concepts. Extraction of metals is for aluminum, really. That's the big one. We didn't really have to go over that now. Electrorefining and electroplating. So electrorefining is rather simple. It is, let's say we have a rod, a brick of metal, and it have a lot of impurities in it, and we want to clean it up. So what do? We electrorefine it. So a proper definition would be, I honestly don't know. The process in which materials, usually metals, are purified by means of an electrolytic cell. So, as we could see here, it's also called electrowinning apparently. Wow, that's an awfully low res thing. This is extremely low res, we won't use it. So, I will demonstrate. I know I draw the battery wrong, I don't care right now. Okay, we have the cathode, we have the anode, and we have the electrolyte. Cool. So, what is what? How do we electrorefine? Well, it's pretty straightforward. The anode is the impure metal. The cathode is a very thin strip of the pure metal. This means that the cathode is active. And I don't put this to confuse you. And then the electrolyte is an aqueous solution of the metal being purified. I don't even know if electrorefining on the Csec syllabus, but that's what it is. Cool. Now electroplating. Electroplating is extremely simple. I have a set of notes on it. I will put it. So electroplating is when you coat a substance with another metal, and it can be more or less reactive in order to protect it. We will go over that later on. Anodizing. I don't think this on the Csec syllabus. The anode is what you want to coat your object with, and the cathode is the object to be electroplated, and the electrolyte is so I'm gonna type that out. Anode is a pure sample of the metal used for plating, and the cathode is the object to be electroplated, and the electrolyte is an aqueous solution containing ions of the metal to be used for plating. So I have some examples up here in the notion. So here we have anode is a pure metal, wants to go the object with, and the cathode is the object to be electroplated. There's an example down here. Nickel plated. It is also used to improve the appearance of metals, which is coating cutlery and jewelry with silver. So, let's say we have a spoon and we want the spoon to be coated with gold. Okay, so how would we set up that apparatus? Battery, we have the cathode, and we have the anode. So the anode is a pure sample of the metal to be used for placing. So let's say we want to cover it in gold. So this is a pure strip of Ag. And this over here, this is a spoon. So I will draw a spoon. Spoon. Right. So what happens is electrons move from the Ag minus. My bad. From the Ag plus goes this way, this way, this way, this way, and onto the spoon. Okay, now you might be wondering, but this have a plus charge, then it would become Ag2 plus. Yes, that would happen. That's normal. I don't know why this happened. Oh, I do know why this happens. That see, you need to know the reaction. Okay, I will probably come back to this in the future because I need to revise this. But yeah, the electron moves from the gold moves from the anode to the spoon. The electron moves through here and it moves through the electrolyte to get back to the spoon and it forms the coat. There's a video. We will watch the video. The video is very long. I will put it in the description, and I'll put the link to this page in the description. Anyways, that is about it for electrochemistry. It's quite simple, in my opinion. Now, we just went over the whole thing in 22 minutes. So, that's that. I will do logarithms for AdMax later. Whee! So yeah.